All right, welcome to the second counting video. This time we're going to be discussing something called the pigeonhole principle. Now, this is one of my favorite ideas in this type of mathematics because it is deceptively simple. Okay, so first let's see what the pigeonhole principle actually says as a mathematical statement. Kind of. If n plus 1 pigeons are in n pigeonholes, then here's the best part. At least one pigeonhole contains more than one pigeon. And I just noticed there's a typo right there, which I will add to the errata on GitHub. Okay, so if you have n plus 1 pigeons and you're going to put them in n pigeonholes, okay, notice you have one extra pigeon, then at least one hole contains more than one pigeon. Let's look at this example. Here we have, let's see how many pigeons we have. So we have one pigeon, and here is a second pigeon. So there's two, and then 3, 4, 5, 6, 7, 8, 9, 10. So I have exactly 10 pigeons, and I want to put them in, well, 3 by 3, 9 pigeonholes. Well, the pigeonhole principle says at least one hole contains more than one pigeon. And in this case, this first hole contains 2 pigeons. That's the only way you can shove 10 pigeons into 9 pigeonholes, is that if at least one of them contains more than one pigeon. This is surprisingly useful to answering lots of different counting problems. Let's look at an example. So if you have a group of 367 people, at least 2 will have the same birthday. Okay, why is that true? So when you're doing these types of problems, it's useful to think of it like this. What are the pigeons and what are the pigeonholes? That is, what are the categories you're trying to put people into? Well, in this case, the pigeonholes are going to be the days in the year. Well, there are 366 possible days in the year, counting leap years. And the pigeons here are going to be the people. And you have 367 people. Well, if you want to put 367 pigeons into 366 pigeonholes, at least one pigeonhole, which is a day of the year, will contain the same people. We'll get more than one pigeon, which is more than one person. That is, at least one of those days, January 1st through December 31st, will have more than one person having a birthday on that day. The you try example says how many people with English names have to be in a room for 2 of them to have a first name that starts with the same letter. Well, in this case, the pigeons are going to be people, and the pigeonholes are going to be letters of the alphabet. There are 26 letters of the alphabet. So if you want to have 2 of them that start with the same letter in their first name, you have to have 27 people. Because if you have 27 pigeons into 26 pigeonholes, at least one of the pigeonholes, the letters, has more than one person in it. So if you have 27 people, at least 2 of them have to have a first name that starts with the same first letter. And that's basically it. This is the pigeonhole principle in a nutshell. Now, we are going to, in the practice problems, see how we can expand this just a little bit, but this is really it. This is the primary idea. Okay, let's look at the notes. This really is a case where watching the videos will give you a lot of information because there are 3 more examples applying the pigeonhole principle, and then all of these practice problems. Okay, Let's do a couple of them. Number one, how many students must be in a class to guarantee that at least 2 students receive the same score on the final exam if the exam is graded on a scale from 0 to 100? Well, in this case, the pigeonholes are going to be grades. So a person can score a 0, a 1, a 2, a 3, all the way up to scoring 100. And the pigeons are going to be people. So so we could have like one person that scores a 0, a second person that scores a 1, a third person that scores a 2, a fourth person that scores a 3, all the way down to a 101st person that scores a 100 on the final exam. But as soon as we go to the 102nd person, that has to be a repeat. That must repeat a score. This is the same idea that we did with the first letters of the first names. The 102nd person has to repeat one of those first scores. So the answer to this one is you have to have 102 people in a class to guarantee at least 2 of them receive the same score, where grades can be 0 to 100. So 102 is the answer. Now we can expand this a little bit and it gets more interesting. How many students must be in a room in a class to guarantee at least 5 of them receive the same score in a final exam? Well, again, here are going to be the grades, which are the pigeonholes. The grades are going to be 0, 1, 2, 3, all the way down to 98, 99, 100. And now I'm going to make a list of people. Okay. The first person could score 0, the second one could score a 1, and so on and so forth, just like we did before. So the 99th person could score 98, the 100th person could score a 99, and 101st person would score 100. Now, this is kind of a worst case scenario where they're all different. All the people score something different. Okay, let me draw some lines here so we can kind of keep track of what's going on. Now, I could have my 102nd person could score 0, the 103rd, 104th, 105th, okay, down to the, what is this going to be? This would be the 202nd person, 201st person, and the 200th person. So I could have 202 people, and in this case, I could have 2 of each. Well, what happens if I could have 3 of each? This would be the 203rd person, 204th person, and so on and so forth. So I'm going to let you figure out what the end would be, okay? I could have 303 people, and they all would, and I could have all of them, and I could have each score being given to 3 different people. Well, how would that happen with 4 different people? And what is the minimum number I would need to have at least 5 of them with the same score? So kind of extend this idea a little bit and see if you can figure it out. And this last problem is one of the exercises in the book, but I'm not going to solve it completely like I didn't do the last one, but this is just one of my favorite types of problems. So let's think about this problem. Give an argument that at least 2 people in Atlanta, or actually any large city you want to use, have the same number of hairs on their head. So think about what's going to be the pigeonholes, and then what's going to be the pigeons. Well, the pigeonholes are going to be the number of hairs possible. Well, we could have a bald person. We could have a person with only 1 hair on their head, or 2 hairs, or 3 hairs. And so the max number of hairs. This is something you could look up on Google. Find out what is the most number of hairs a person could have on their head. And the pigeons would be the number of people in Atlanta. So we know there's, there could be one person in Atlanta, 2 people, 3 people. We know there's not, but you would go down to and see, well, what is the population of Atlanta? And if the population of Atlanta is larger than the number of hairs that a person could have on their head, well, we have more pigeons fitting into holes, which means by the pigeonhole principle, at least 2 people have the same number of hairs on their head. So look up those 2 pieces of information. You could look at the population of Atlanta or whatever large city you want to use and how many hairs people have on their head, and then try to answer that problem using the pigeonhole principle. And that's it. This is a short video. Again, read through the textbook and the notes, watch all of the example videos, and that's it. The next video will be about combinations and permutations.